Hello there, this is Miss Nakayama. Today's lesson is 6.3 polar coordinates. So this is new for y'all this year, and I hope you think it's as much fun as I do. Not very hard, but once you get it to click, I think you'll find out that it's pretty fun. Okay, so what we're going to talk about in this lesson is actually plotting points in the polar coordinate system. We're going to find multiple sets or names, and then we're going to do a lot of conversion. Okay, we are converting from, first of all, we're going to convert points from, and we're going from polar to rectangular, and then we're going to go from rectangular to polar. And then after we do points, then we're going to talk about converting equations. And again, we're going to go from rectangular to polar, and then we're going to go from polar to rectangular. So I'm trying to point out that it's really all the same thing. You just have to know how to go back and forth and use certain equations. But before we start, let's talk about what a polar coordinate is, what that polar coordinate system is. Okay, so they say that the foundation of that polar coordinate system is a horizontal ray that extends to the right. Okay, before I go there, I want to talk about what you already know. So up until this point in your life, you have always graphed points on a coordinate plane where this is our x-axis and this is our y-axis. And you move left and right according to the origin right here. So if I had the point -2, 4, then from the origin you would go left 2 and then up 4 and plot that point. Okay, that's what you've done in the past. Now we are going to use the positive x-axis, and that's going to be referred to as your polar axis, and it's all going to rotate around the pole, which is the origin. Here's our pole right here. Okay, so we have the pole. Actually, kind of had that named. So here's our pole, here's our polar axis, and then we're going to have this point. Now, this point back over here in our previous ways, we had x comma y. Okay, now we are naming the ordered pairs as r comma theta. R represents the distance that the point is from the pole, and theta represents that angle from the polar axis. Okay, there's my point, r theta. Y'all, we're back to always measuring from the horizontal. Okay, the only time we did the vertical is if we had the word bearing, and we're not going to have that in this chapter. So you have your polar axis, you have your theta, and then you have your length. Your distance, the point is from the pole, and that is your r. Okay, keep in mind that r can be either positive or negative, just like both our x and y can be positive or negative or 0. Okay, so can that r value in our ordered pair r theta. The angle, positive angles are still measured counterclockwise, negative angles are still measured clockwise. So what you're going to see us doing, I'm going to go ahead and go. Let's just go and do some examples. So here are 3 examples, and we're going to plot the points. Now, remember that the points represent r and theta. When you plot this, you're going to start plotting here. I mean, it doesn't really matter, but most of the time, you're going to start with the angle, and then you're going to go figure out how far it is. So the other thing, I have some rather simple polar graphs. Okay, the ones that you see in my math lab actually have each of these divided again. Okay, but what you need to know, if you do not know already, halfway between 0 and pi over 2 is pi over 4. Okay, so halfway between these 2 lines is pi over 4. That first line is going to be pi over 6, and that second line is going to be pi over 3. So if you don't know that, you need, I said pi over 3, but I did not write pi over 3. Okay, pi over 3. So I'm going to go find 2 pi over 3, which is right here. Okay, so You can label that if you want to. That's 2 pi over 3. And then I'm going to go out a distance of 6. So I count from the origin, and basically you're counting the rings on that line. So 1, 2, 3, 4, 5, 6. And that's where my point is right there. Okay? Look at the next one. I have negative 2 pi. Okay? Everybody knows that pi is over here. But what you have to think about now, pi, that is the direction. This is the direction that you're facing. But from here, we don't walk a positive 2, we walk a negative 2. So that means we're going to walk backwards, and it's going to be right there. That's where it is. So the angle is telling you which way you're facing, okay? The number in front says whether you walk forward or backwards. So that same thing is the negative is always a direction. Okay, let's look at this last one. Negative 1, negative pi over 2. So positive pi over 2 is here. Negative pi over 2 is down here. So I'm facing negative pi over 2, so I'm facing down, but I have to walk back 1. So that's where it is. Now, if you can see, I'm going to show you this. This point is called negative 1, negative pi over 2. But it could also be named positive 1, pi over 2. Because if I turned and such that I was facing pi over 2 and walked out 1, then I'm going to be at the same place. Okay? So another name for this guy here, I was facing pi and I walked backwards 2. Well, if I wanted to walk forwards 2, okay, then I would be facing 0. So that's another name for that point. Okay? And that's part of what you have to be able to do, is be able to change coordinates, because there are an infinite set of points, because you can go around the circle an infinite number of times. But look at this here. We have 5, comma, pi over 4. That is my r and my theta. Okay? And you have to go name 3 other points. So when I did this here, I just named 1 other point, but you got to name 3 other ones, and they give you some directions. They say, keep r positive, because r is positive right here. So keep r positive, but make it between 2 pi and 4 pi. Well, that means that I'm just going to take my pi over 4 and add 2 pi to it. So when I add 2 pi to that, your calculators will do that, then you're going to get 5, 9 pi over 4. Okay? Now, if I want my r to be less than 0, so this is a negative r, b is a negative r, but a is a positive r, and c is a positive r value. Okay? This time, this is more of like what happened up here. I changed the r values. And if I change the r values to negative and positive, okay, how far apart are the angles? Those 2 angles or these 2 angles? How far apart are they? I hope you can see that that is pi. So what am I going to do this time is I'm just going to add pi to it. And my answer is going to be negative 5 pi over 4. And on the last one, r stays the same, but this time they want a negative r. So a negative theta. Okay, this says give me theta between negative 2 pi and 0. So I don't want a positive theta, I want a negative one. So this time I'm just going to subtract 2 pi from it, and I'm going to have 5, negative 7 pi over 4. So if you haven't figured out already, a general rule of thumb when you have to rename them is if you have the same r value, okay, this one's positive and that one's positive, the same r value means you're just going to add or subtract 2 pi according to your directions. And if the r switches to the opposite r value, then you're going to add or subtract pi. And that's what I just did in those 3 examples. Okay? Now, those are points. Now we got to talk about, well, we're still going to switch. How to change between polar and rectangular coordinates. Okay? These 4 equations are the most important and what you need to know. Now, first off, if you look at this diagram, that purple dot up there, represents r theta, but it also represents xy. So if you think about the fact that x and r, okay, you know that the cosine of theta is equal to x over r from SOHCAHTOA, or the sine of theta is equal to y over r. Well, if I solve that for x and y, that's where these two are coming from right there. But you're going to use it a lot. You don't want to have to go through the process of solving it every time, y'all. So if I know r and theta and I want to go to rectangular, so polar to rectangular, I'm going to use those two. This next one, x squared plus y squared equals r squared, that is not new. And tangent of theta equals opposite over adjacent. But these are the two equations that we're going to use when we go from rectangular to polar. But I'll write them every time we do it, okay? That's exactly what that's saying. So this time we're going to go from polar to rectangular. Polar is r and theta. Rectangular is x and y. So if I need x and y, that was the first thing I showed you, then x is equal to r times the cosine of theta, and y is equal to r times the sine of theta. And y'all, I keep telling you every time, just write it down every time you do the problem, and you will know it by the time you finish the practice. Okay, so I'm starting off with 3 pi. That's r, and that's theta. So my formula says x equals r cosine theta. So r is 3 and theta is pi. And the cosine of pi is -1. So that means x is going to equal -3. Now I'm going to come up and say y is equal to r sine theta. So I'm going to go plug in r is 3 pi. Theta is pi. What is the sine of pi? 0. And there I have 0. So 3 pi in rectangular coordinates becomes -3, 0. All right, look at B. I have -10 pi over 6. Going through the same thing. X equals r cosine theta. R is -10. Theta is pi over 6. The cosine of pi over 6 is square root of 3 over 2. So this becomes -5 square root of 3. Then I'm going to go do y. Okay, y equals r sine theta. R is -10. Theta is pi over 6. The sine of pi over 6 is 1/2. -10 times 1/2 is -5. And so my rectangular coordinates that go with the polar coordinates are -5 square root of 3, -5. It's pretty straightforward, y'all. And we're always using some variation of these equations. So you ought to write them down every time they do the problem. You will know them. Okay? So this is going the other way, but I'm going to show you as we go through and do it. This time, okay, we are going from rectangular. Remember, rectangular is x and y, and we're going to r and theta. So if I know x and y, it's not what we just did. X squared plus y squared equals r squared. If you want to solve it for r equals the square root of x squared plus y squared. But I think both of them are helpful, y'all, because there are times when I have people get in a mess and trying to convert back and forth when they only use this one. So be careful. You need to remember this one also, which you should know from the last chapter. All right, tangent of theta equals y over x. So theta is the inverse tangent of y over x. If I ever need the angle, then I'm looking for the inverse tangent. So I have a problem. Find the polar coordinates of the point whose rectangular coordinates. So when they tell you rectangular coordinates, that means this is x and y. And I've got to go find r. So we can go ahead and say r is the square root of x squared plus y squared. And I've told y'all over and over again, if you have a negative and you square it, you don't need to put that negative in there. Because whenever people do, they make mistakes. So I'm going to write 1 squared and the square root of 3 squared. 1 squared is 1. Square root of 3 squared is 3. So r is the square root of 4, which is 2. And now I'm going to come back to theta. I'm looking for theta. Theta is the inverse tangent of y over x. And y is the negative square root of 3, and x is 1. And so that gives me the angle of 2 pi over 3 or 5 pi over 3. And so every time you're going from rectangular to polar, you need to remember to check the quadrant. Okay, the point of 1, negative 3 is in quadrant 4. And which of those two angles, 2 pi over 3 or 5 pi over 3, is in the fourth quadrant? Well, that, of course, is 5 pi over 3. So that means my answer is going to be 2, 5 pi over 3. If you plot it, y'all, you won't have that problem and make that mistake. But you do have to remember to check the quadrant every time you do it. Okay, so that was points. Now we're talking about equations. We're going to use the same information. But this is so with points, these are okay to use. But with equations, like I'm fixing to go into, these are better ones to use. Okay, so you need to practice all of these problems, y'all, because there are multiple little tricks of knowing how to do these things. They're not, you know how to do one, you know how to do all. So be careful. We are going from rectangular to polar. Okay, so that means I start off with an x and y, but I can only have r and theta in my answer. So x is equal to r cosine theta, y equals r sine theta. So I'm going to go immediately substitute. X equals r cosine theta and y equals r sine theta. I'm going to distribute my parentheses. 3r cosine theta minus r sine theta is equal to 6. And when you find these equations, you have to solve for r. So this is probably the hardest part of the problem. You got to factor that guy out. So when I factor it out, I'm left with 3 cosine theta minus the sine of theta. And then I have to solve it for r, like I said. So I'm trying to get this guy by itself. So I'm going to divide by that expression. And that's going to give me 6 divided by 3 cosine theta minus sine theta. Okay? I can't encourage you enough to practice all these equations, y'all. Okay, look at this one. I got x squared plus y plus 1 squared. Now, you can substitute at whatever time you want. If you want to go ahead and put r cosine theta here and r sine theta here, you can do that. But I'm going to show you another way that you can do it. And that is you can go ahead and expand this. So x squared gets carried down. But when you do y plus 1 squared, that's that same thing y'all have been talking about. A plus b quantity squared. You square the first one, multiply by 2, multiply them together times 2, and then square the last one. So 1 times y times 2 is 2. Well, first of all, y squared. And then 1 times y times 2 is 2y. And then square the last one equals 1. Okay? And now you can see that my 1's are going to cancel out. And this right here, y'all, is r squared. So it's a little bit easier to square. People have a little more challenge. If you put r sine theta here and then try to do this to it, people have a tendency to mess that up. Anyway, so 2y is going to be 2 times r sine theta, and that's equal to 0 because my 1's canceled out. Okay? It's probably easier at this point to take the 2r sine theta to the other side by subtraction. So r squared equals negative 2r sine theta. And then I'm going to divide both sides by r because I'm solving it for r. And I'm going to get r equals negative 2 times the sine of theta. All right, let's go the other way. Again, using those same equations over and over again, y'all. Okay, so look at these two. All right, convert the polar equation to a rectangular equation. Remember, polar means I'm starting with r and theta. And rectangular means I can only have an x and or a y. I can't have an r and theta in there. So if it says just r equals 4, then the way you want to handle that is to square both sides. R squared is r squared. 4 squared is 16. And on the screen we just said, what does r squared equal? X squared plus y squared. And so we have it. You don't have to, well, we will in one instance. But that's all you have to do. Theta equals 3 pi over 4. Okay, in this particular example, you've got to remember. So these are the kind of things you just got to know what to do when it says theta equals 3 pi over 4? I'm going to take the tangent of both sides. Tangent of theta equals the tangent of 3 pi over 4. Well, our formula in the previous slide, okay, what does tangent equal? Tangent equals y over x. So I'm going to put y over x for tangent. What is the tangent of 3 pi over 4? -1. Multiply both sides by x to solve for y, and you get y equals -x. Okay, last two examples. Stop it. Last two examples. Okay, this time, we did that last time, same thing. Okay, so I have r equals -2 times the secant of x. Okay, those four main equations, y'all, none of them have secant in it. They only have tangent, sine, and cosine. So can I write secant in terms of the cosine? I can. Its reciprocal is the cosine. So if it's secant on the top, then I know it's going to be cosine on the bottom. Then I'm going to multiply both sides by cosine because I know that r cosine theta equals x. So x equals -2, and that's the rectangular equation. All right, last one. R equals 10 sine theta. Okay, so last time, if you noticed, every time when we've had r, y'all, okay, here we squared both sides. Here I changed it to a different name and then multiplied. And over here, I'm actually going to multiply both sides by r. So I'm doing something different in every time, and you just got to be familiar with it with practice. So r times r is r squared, and then I'm going to have 10 r sine theta. Well, what does r squared equal? X squared plus y squared. And r sine theta right here is equal to y. So I'm going to have 10y. And in MyLab Math, you actually have to put that in standard form because I have more than one variable. I mean, I have, like before, you could leave it like this, x squared plus y squared equals 16. But because x squared plus y squared equals 10y, we actually have to complete the square. So I'm going to bring the 10y over, and that's going to give me x squared, and then I'm going to have y squared minus 10y, and then I'm going to plus a blank on both sides to complete the square. Completing the square is half of 10 is 5 squared to both sides, and then that factors. So I'm going to have x squared, and then y minus 5 quantity squared equals 25. And that is our circle. So it's a circle centered at 0, 5 with a radius of 5. So we're going to learn more about the graphs in the next lesson. But right now, what you need to know, and you need to write them down every time you have an example, are these four equations. These are the key to having success in going back and forth between polar coordinates and rectangular coordinates involving points and equations. Thank you so much for watching, and y'all have a great day.